In 5 minutes, learn how to take full advantage of the UBC-GIF codes within Geoscience Analyst by running an unconstrained inversion and visualizing the results in an integrated 3D environment. In this workspace, we have regional airborne magnetics observation data and its uncertainty, a mesh, and a topography surface. With this data, we are ready to start an inversion using MAG3D through Pro Geophysics. From the Geophysics menu, create a GIF tools group. Then drag the data into it, and since we're running a MAG3D inversion, we can leave the type as total field magnetic data. Now we can right-click on the GIF tools group to create the magnetics inversion. And create a folder, and this is where all the files will be exported. Prior to the inversion, we can specify several options. Right-click on MAG in v3.3, Inversion, Edit Options. To do so, select the required input data, the observed data, the mesh, and the topography data. We can control wavelet parameters, use the distance or depth weighting, add cell weight, edit the lower or upper bounds, along with other inversion options. And once satisfied with the inversion settings, we can apply these options, and then write the files, so that now all the input files needed have been exported to the inversion folder. And we are ready to run our inversion. Right-click on MAG in v3.3, Inversion, Run Programs, All Inversion Programs. When we run MAG3D, it'll go through the weighting file, compute a sensitivity matrix, and then start the inversion. While the inversion is running, we can track its progress. Right-click on MAG in v3.3, Inversion, View Convergence Curves. The red line is the misfit. How well do the iteration results reproduce the observed data? The blue line is the model complexity. As you can see, where our model is least complex, there is a large data misfit. To reproduce the data, we would need to change the model, making it more complex. Now that our inversion is done, we will load the results. So right-click on MAG in v3.3, Inversion, Load Results. We have the option to load only some of the iteration's results. In this case, we will load them all. It has copied our files, including the inversion results, so note that since all the objects are copied, the inversion is completely reproducible. So in the mesh, we have the iteration results. In the data, we have the actual data that was used. We also have the predicted data, the misfit, and the normalized misfit for every iteration. To quickly analyze the inversion results, we will look at the original magnetics data and scale it by the normalized misfit. We will begin by painting by the original data, but sometimes points are a bit hard to see, so we will edit the visual parameters, changing the points to spheres, size 30. Select Scale Nodes by Data, and we will scale by our last iteration's normalized misfit, and scale by 3.0, and let's scale by the absolute value. Where there is a large sphere, we didn't really fit the data as well as we could have. If we select one of these large spheres and look at its value in the data table, we will see that the normalized misfit is within 6 standard deviations of what we set. We are not really fitting the data. If we select a small sphere, we will see the normalized misfit is within 0.03 standard deviations. We may be overfitting the data. Essentially, the ideal result would have equally sized spheres with normalized misfits close to 1. Painting by the observed data helps us analyze further. If we haven't fit the data perfectly in the background area, it isn't too big a deal. On the other hand, we would really like to fit the data better where there are anomalies. And we can also investigate the recovered 3D model. We can turn on the mesh, display the last iteration result, and change the color mapping functions min and max. We can make the data smooth and move the block model sections to view the anomaly. The mesh's padding can also be hidden by creating a volume of the appropriate dimensions and clipping the sections. As part of our results, the log file for our inversion is available in the Files section of the Data Table panel. In the GIF Tools metadata, we can see all the inversion options that were used, including the input data, weighting objects, reference models, upper bounds, lower bounds, sensitivity weighting, and working directories. If we click on the input data, for example, the mesh used for the inversion will be highlighted in the Objects panel. And there you have it, a MAG3D inversion in 5 minutes. Thank you for watching.